So, welcome to what everyone ought to know about aesthetic single tooth implant restorations. It is a webinar being presented by Jimmy Stegall, a National Procedural Solution Specialist for Dentsply Sirona. And with that, it is my pleasure to introduce Mr. Jimmy Stegall. He is a seasoned dental lab operations and management executive with more than 40 years of teaching and clinical experience in the US and Canada. He is a published author and has assisted in research projects with dentists, universities, and manufacturers. After a successful 30-plus year career helping to build and lead a large dental lab in South Carolina, Jimmy served as a division president of a large dental lab network, and he is now a national procedural solutions specialist for Dentsply Sirona. As a key opinion leader, teacher, and trainer, Jimmy has demonstrated a history of bringing results-oriented strategies and techniques to dental practices and labs throughout the U.S. And with that, I get to say, take it away, Jimmy.
Thanks, Jessica. Good to be with you again. And tonight's topic is to talk about things that can prevent this from happening. A lot of us have seen this with patients in the chair after a period, a year, 2 years, and they're wondering why is this showing? What is this showing under my gums? And this is we've unfortunately I saw this quite often in my career and early on before we learned some things, and that's where we're here to talk tonight about. We're going to talk about the proper ways or the best ways that have been proven to prevent this from happening. So in my opinion, to eliminate that chance or greatly reduce that chance, I think it's all about customization, right? When we talk about customization, we're going to talk about customization in all aspects of the single tooth implant treatment, right? Starting in the beginning with the plan and going all the way through the preparation, the provisionalization, the impression, and the final restoration. All about customization, which will drastically reduce the chance of us having tissue loss, right? Because the technology's there, the equipment's there. Then we're going to finish with, the digitization, because I think that greatly enhances our chance of success as well. So show you some things about how that workflow looks. And so we'll start with looking at a case that was, the surgeon and I talked about it. Do we want a surgical guide? So this was years ago before surgical guides were super popular, or most surgical guides were made manually. But we had these images that we looked at, patient, and I think if most of the time surgeons or folks that are placing implants in this particular case would say, no, I really don't think we need a guide. I think that's front of the mouth. I can see it well, so I can access it well. Pretty good with my hand in the drill. I think I can get that implant in the right position in this particular case. In actuality, we did this case with a plan, right? And this is the steps, and you can see the between the red and the green tint of the implant. That is just a change in position, so that we're just kind of tweaking it, perfecting it, letting the computer help us. And that's the beauty of planning for implants, is that the software tools we have take real good advantage of the images that you guys are creating now with the CBCT and the digital impression devices. And we can take that data, we can input it into this software, and this software will help us. It will guide us, it will direct us as to where the implant should go. We will tell the software things like what implant we want, and the approximate location, what size we want. And it will say, this is good, this is bad, and it'll help direct us into that placement, ideal placement. So, here's the steps of the case. And, when you look at this guide, the things you should recognize is that number one, is it fully seated? Number two, the rims in the middle indicate that it is a fully guided guide. So as you can see in the second image on the top right, the implant will actually be going through the guide. So a fully guided guide just means that we're going to put it in and we're going to leave it in while we go through all the drill steps and the implant placement. All right, we're talking single tooth implants now. There are other sophisticated things for full arch these days, but single tooth implants, we like to use a fully guided guide because it is the most predictable and the most accurate. But there are lower cost guides out there, right? We call them starter guides or template guides that we put them in, and we'll use it to drill the first pilot hole in the bone. and then we'll take the guide out and do the rest of it freehand. That certainly is a viable option as well. But as I look at the bottom left picture, and I've been looking at this picture for years and always wondered to myself, had we done this freehand, is that where the implants would have ended up being? You never know, right? We did it with a guide, so this is where they are, and so you have to look at the results. The bottom right image is of the temporization, which we're going to get into how we do this particular temporary, but I think it is critical to the success of this tissue. So you can see at the upper left the after the healing, right, and you can see how the temporary has done what we really needed it to do. By customizing that temporary, we were able to customize the tissue platform. And it's not just a hole in the tissue that we have to work around, right? We're actually building that platform to what we specifically want it to be for an ideal result. And as you can see, we got pretty good results. We have a little bit of embrasure on the distal of one of the laterals, but overall, we were very, very pleased with the success, and the patient has done well for quite some time. So, that's kind of my argument case quite often for whether or not we should use a guide. And today, my opinion is that we ought to use a guide for every implant placement. I think it really eliminates a lot of risk. It really helps us get it in the right place. And of course, the computerized planning of that guide takes into account what the restoration is and where it's going to be. Right, so it is a crown down or tooth down workflow in the digital space that helps us get the ideal exact position for that implant. Right, so she said, I'm from South Carolina, so this is down near Charleston, right outside Folly Beach, and it's just a beautiful part of the world, and we always love to have company, so come visit us down here. So we talk about the implants just for a second, right? And, it used to be that the conversation with implants was all about bone preservation. Right, nobody wants to be in one of these. As good as we've gotten at making these and delivering these today to help those patients, nobody sets out to say, I want a full arch, implant restoration. So we've got to save bone. We've got to help people save bone, and of course, single tooth implants do that. But there was a time in my career, and in some of yours, that the key to bone preservation was the implant we were placing. There was a time when losing a millimeter and a half of bone over 5 years was an accepted norm. That is not the case anymore, right? We want to use implant technology that gives us really, really good bone health. And, thankfully we have that today with most all the major systems, right? Right? When you look at cases like this and you think, oh my gosh, what happened? And the reality was early on, some of this was caused by the implants themselves because they didn't have the design or the fabrication methods or the threads or the treatment on the surface that we needed to prevent this from happening. And most of it was because of the internal connections. As you well know, implants started out being an external hex, right? A hex sitting on top of an implant that we would put something on top of. That's a very unstable physical piece of engineering, right? Things are going to move a little bit. So when it moves, there's percolation. And when there's percolation, then, bacteria stays where it shouldn't. And we start to see, angry tissue, and then you'll eventually see angry and bone that's not there anymore. So it scares me to look at some of the older pictures like this and see how fast this actually can happen. Again, like I said, fortunately we have much better implants today, right? And the big change with implants came when the internal connection changed, right? When the internal connections changed, we really saw a rapid increase in bone health around implants, right? And like I said, we started with external hex, we moved to internal hex connection, and now most everyone is doing a conical connection, which is the best by far. Or in this image, no connection, I guess, was the norm for that day. So if you're looking for an implant today, right, what is it that you're looking for? Well, you want it to go in and stay in long term, right? I want it to perform. I want it to be easy. I want all the parts and pieces to be easy to understand. And I want to be able to use it wherever I need to use it, right? So, that's kind of what you look for. And when we try to, or when we look at implants and say, okay, how did we get here? Well, as a lab guy, I would sit at the bench and I'd see all this bone loss and I'd think, man, why is this happening? And so in the beginning, I didn't really care, right? I was pretty agnostic. I'd let my customers, they would use what they wanted to use and I'd say, okay, I'll restore it. But, as we started seeing these failures and bone loss, I really dug into it and started looking at the research real close and seeing, what was the cause of bone loss and all that. And, what I noticed almost right away was that the Dentsply implants showed very little bone loss compared to the others. It was one of the best ones. And so you dig into that further and say, what is it they're doing different? Well, Dentsply was a company that brought conical connections, internal conical connections to implant restoration. So when you take something and screw it into an implant, when you've got a long tapering conical connection, you've got a much better seal and less movement. So that means less percolations. That means greater bone health. So they were the first one to do it. And then the micro threads up at the top, say 10 millimeters of an implant, right? That was a Dentsply invention as well. And that helped a lot with the bone health right around the cervical portion of the implant in the bone. And then finally was the way the surface treatment, whether it was sandblasted or coated with something. The one that tested so well, again, was an implant developed by Dentsply. So I looked at all that research and I said, well, why is it in my lab I'm not seeing a lot of Dentsply implants, right? If they're the best, and you dig into that and you realize, well, a lot of implant sales have to do with just that, the salesperson and, the region and all that. And of course, cost always had a factor. But today, fortunately, when we look at implants, we can see that, conical connections, micro threads at the top, and the specialized coating is pretty normal, right? So, thanks to Dentsply for making it all happen and leading the way. But you can feel safe. If you're staying with most of the big names, you can feel safe today that you're going to have great bone health. And the norm today, 0.2 of a millimeter over 5 years. So we've really improved it, right? This is a 10-year-old Astratech that there's virtually no bone loss around that implant. So that's exciting. And so number one, we got to pick the right implant. Pick the right implant so that we don't see that kind of bone loss. But then, we got to start thinking about the tissue after that. And I soon learned that tissue is always the foundation we need to establish first. And this was a case we did that it was the norm, right? I would get the impression and I would see a little small hole where the impression post was in the tissue. And, I just logically said, okay, I've got to come up and out of that tissue and build a restoration. And as you can see, at the cervical portion of the crowns, I call it a shoulder or a shelf. And that's just the nature of the beast when you have a skinny hole and you've got to put a crown that's bigger than that hole up there. And I guess I was the most naive, dental technician in the country where I just assumed that patients would clean this, right? I knew that it was going to be a problem. I knew that it's going to be a place that food could get caught and bacteria could grow, but assumed that if the patient was doing this, they would clean it. Well, we've learned that pretty quickly. So, after seeing this for several years, we've got to come up with a solution, right? So instead of a tissue punch and a hole the size of the implant, right, we've got to figure out how to deal with this tissue. This was a molar done, this molar on the upper left and lower right. The upper left was like in that small hole, right? And we call this a popsicle on a stick crown. And they were very common with labs, some just a few several years ago. And this is more like a pancake on a stick, I guess. But it was soon evident to this patient that this was not going to work. Food entrapment under the mesial and distal, and so we came back, looked at it, and said, "Oh yeah, we've got to do this." So we went back and did some tissue work and did a custom abutment, custom crown, and we had the emergence profile that really should have been there all along. So as you're looking at ads or you're looking at options that we're going to talk about, always be thinking about that shoulder that I mentioned. When you are, looking at a molar like this and you see that shelf, right? This is a stock part, right? So a stock abutment, we got to build it out to get to the proper contour, and it's going to leave that area that things could go wrong in. Just be aware of that, right, as you're planning and thinking about it. And that's what you want to avoid that tissue loss to that unhappy patient. We're going to talk about all the ways to do it. So, this is what I was seeing almost on a daily basis with the single tooth implants, right? Good impression post. The tissue's healthy. It's awesome. It looks wonderful. But what we've got to do is we've got to get to there, right? You want that tissue to be what I commonly call anatomically correct. Right, I want that tissue molded, contoured, shaped as to the understructure of what that tooth would be, right? Like if it's a recent extraction and automatically could get healthy, all right? That's what I want to see there. So we've got to build that, right? You have to create that from the beginning. So in today's world, when a surgeon asks me, well, what's my easiest path to get there? Well, fortunately, the manufacturers have done a really good job of giving us some tools to do that with. Today, you can order these. These are from the Dentsply Tech system. And if you look at them closely, you'll see that these are what I would call anatomically correct healing abutments. So it's a simple place the implant, screw one of these in, matching to the tooth you're restoring, and let that tissue heal up around it in that configuration, and boom, you've got it. Now, it's a pretty general, it's not a true 100% custom to each and every patient, but it's close. And this would be my favorite, easiest way. So we'll put that in and let that tissue just heal around it. We'll get it. Now, I didn't have these before, right? These were not in existence. And, when we're doing restorations, right, we want the restoration to be as close to the natural tooth structure as possible, right? Patients don't come to us for implants, they come to us for teeth. So when I didn't have those other anatomically correct healing abutments before, I would have to manually build those until this one came out. So this one, Contour Healer, developed by a dentist in Virginia Beach, makes them out of a pecton type plastic, autoclavable, usable over multiple times. And he made them for a lot of different implant systems. And these were the most anatomically correct I had seen. Remember, the metal ones weren't around at this point. If I had anything custom, I made it myself. But when this came out, this was a godsend for us. And just look at the tissue shape we're getting with these things, right? And this was the easiest path of entry, right? So I started ordering them like by the dozens and handing them to all the surgeons in Paradise and anybody that placed implants. Please put one of these in. Back then we weren't real keen on immediate load, so it was basically place and heal. So this is what we did, and this is still very viable today. I love these contour healers, right? They really get a great tissue response, and they get a great anatomy. They really are well thought out as far as the shape of the tissue goes. And so you can see I've used them on multiple implants. That's Nobel's, Straumann, Dentsply's, and that's the way we do it today, right? You can get one that's been around for a while. You can get one of the newer ones that the manufacturers are doing, but just get one, right, and get it in there, and let's build that tissue. Now, all right, patient's in the chair. We've got to do something, and all we have is a cover screw. Well, what I'm going to do if I'm helping you at that point is to go get a temporary cylinder, and I'm going to build a custom cover screw, right? I'm going to take a temporary cylinder and cut it down, and I'm going to take acrylic or composite, and I'm going to build and shape and smooth and contour and polish and get that customized cover screw to the shape on the underside that we want it to form that tissue exactly. It takes a little time, a lot of handwork, but that's so much better than just putting a cover screw on it. And on the far right, you'll see, what a lot of what we did before we had any of these stock things that would help us. That was to build a plastic abutment and a custom temporary crown on top of that to shape that tissue. And I call that my temporary abutment crown assembly. So, customize the plan through a guided surgery software and a guided surgery placement, right? Customize the tissue by using some sort of device that shapes and molds that tissue. And then we're going to customize the restoration after that. So this custom temp abutment that I did, right? In the beginning, I would take the metal cylinder you see on the right. We would take composite and we'd build it up and we'd shape it and shape it and shape it. It took a lot of handwork, but it was well worth the effort to get that tissue we wanted. Now, the manufacturer started coming out with these preformed abutments, right? And that made my job a lot easier, right? It was a better starting point. And if I look back at it now, really, it isn't that I use the contour healer or the metal anatomically correct or hand make one of these things. That's not the point. The point is, and what I remind myself in my mind's eye is that I'm looking for tissue like this. I'm looking for the nice socket shape of whatever tooth we're restoring, right? I want that inverted shape of that tissue to be formed by whatever we're putting in there. But this was popular, still is today, right? If we want to customize, and this is especially in the anterior, if we want to put a tooth there, right? The patient doesn't want to deal with, say, an Essex retainer or a flipper partial. So, we get a plastic part, we mold it, we shape it, we build a temporary crown on top of it, right? And we deliver, right? And you see that it's a millimeter short and it's out of occlusion. And, a lot of explanation to the patient about what it is, right? You wanted a tooth, but you got to know this is plastic, and it's not real strong, but this will get you over until we're ready to place the final. And they're pretty okay with that. I always would leave these screw retrievable because I would want you to be able to get those out, right? Because if the tissue's not going well, we need to find out why. So we always left the screw access hole, and if the tissue didn't go well, unscrew it. So here's one that Dr. Amin did, and you can see there's the assembly, the temporary crown and the plastic abutment on an analog, right? And we're going to place that, we're going to adjust it, we're going to mold it, we're going to polish it really well. That's the key. Anything touching tissue should be highly, highly polished, right? And then get the patient back in a couple of days. And as you can see, we're getting pretty good tissue at 3 days. And here we are at 4 months, and it's not perfect, but it was a lot better than we started, and it happened pretty quick. And that's because, we built it to normal, healthy contours. So at 4 months, Dr. Amin said it's time for impression. So take the impression post and we're ready to go. And there's the final restoration, 18 months post-op, and you can see the tissue's gotten a better look to it, and we don't have any recession whatsoever, and everything's healthy. Now, all that to say, that's some of that can be difficult. Handmade stuff can be hard and time consuming, and there are some stock parts, but here's a solution that is truly totally custom to your patients, that is totally digital. And I love this one. This is one I didn't ever have when I was chairside. This is called the Atlantis Custom Healing Abutment, and it uses the Atlantis abutment technology to take your digital records and data from your cone beam and your oral scan, and it will look at all that and analyze that in the planning software to not only plan for the implant placement, but also plan for this, which is how tall, emergence profile, all those things. And they will mill this out of titanium, and you can see it on the left. It's got a flat top, so again, it's an anatomically correct cover screw, for lack of a better term. But the beautiful thing about this, that it is also the foundation for your final abutment. So we put this in, and the patient comes back after everything's healed in a few months, and we look at it, and the tissue's fantastic, we love it. Then we don't have to take another impression, right? That data is already existing in the Atlantis computer, so all we have to do is get our lab to say, hey, I'd like the final abutment now, right? And that can be ordered, and the underlying shape, contour, emergence profile, margin, all those things are already predetermined before, so the data's there. So all Atlantis has to do is merge that into a full-size abutment file and mill it out for you. So I love this thing, right? You have to plan for it ahead of time, right? You send your plan in, and they say, okay, here's the way it should look. You okay it, and then they will send you this. Now, you can do that on placement, but what most folks do is place the implant, put a scan post in the implant, scan it, and send that data along with the CBCT up to Atlantis and let them design and mill this abutment. And they will get it back to you in 2 days. And so you'll get the patient back in, uncovered, and screw this thing in and stitch them back up, and then let them go about healing. That's the way that workflow typically works. So we've customized everything to this point, right? The plan, the tissue, the temporary, and if we get that far, right, and I've got this gorgeous tissue site, right, shaped the way it should be, healthy, right, perfect anatomy, the last thing I would want you to do is just to stick an impression post in it and squirt impression material down in that socket. It's unreliable, right? Depending on the impression material, it may or may not like the moisture, and it's fluid, so it may or may not fill the space accurately. The tissue may collapse on it. So I always had our folks do a customization of impression posts, right? And that can be as simple as putting the impression post in and squirting some flowable composite around it in 2 or 3 layers, like curing it as you go, and then take your traditional impression from that. And that results in holding the tissue in its place. Now, if we made one of these, what we did with these is we used this to make our custom impression post, right? So we had this tool. All I need is an inversion of it. So, what we would do is we would take it, the patient's healed, we're happy with everything, so we're going to take it out of the mouth and put it in an analog. Once I get it in an analog, right, I am going to put some impression material. This is Blue Moose bite registration material around that analog and around the underside of that temporary. put it in a little cup and let it set up. Unscrew it from the analog. So, what I've got left is an analog down in that putty, right? But I've got a inversion of the bottom of the temporary assembly. All that's left to do is put an impression post into that analog and put some flowable composite around that. And boom, I've created a custom impression post that 100% replicates the underside of the temporary, which actually built the tissue. So this was an easy workflow. It takes about 5-10 minutes to do it. And, we'd always confirm, of course, and we'd put it in there before we took the impression. Now, lest you think maybe I could get away with squirt impression material in there. This is the same patient, the same day, same case, and with just a regular impression post in there. And if you haven't noticed it yet, the buccal tissue is already collapsing. So, the question is, if I put impression material in it, am I capturing the collapse or will it push it out? And it's kind of an unknown to me. And if we worked as hard as we worked to get that tissue at this point, then, the last thing I want to do is risk not capturing it accurately with some customization. And in a case like this, I think it's critical, right? This was a high smile line, front tooth, anterior, single central, young patient, right? This is one that you don't want back in your office in a couple of years, with that margin exposed. So we've customized everything to this point, right? And so this is where we start talking about, okay, what are we going to put in there after we've got the impression done? So, again, if we were waving the magic wand and, creating our own implants and abutments and restorations, what do they look like? Well, it's pretty easy, right? I want them to be ideal compatibility wise, health wise. I want the tissue be nice around it, and I want it to look like a tooth, right? I want it to act like a tooth. I want it to treat the tissue and bone like a tooth, right? I want it to support everything as if the tooth was there. I don't want it to break, right? It needs to last a long time, and it certainly can't move, right? It's got to fully engage into the implant. And we have that today, guys. You have that in stock parts, you have that in custom parts, and technology has really gone a long way. Now, I will say that, while I'm not a fan of stock abutments, tie bases and things, which we'll talk about one at a time, but they have their place, right? They absolutely have their place and they can be used, but just realize that it's very rare that you can use a stock part and not have a shoulder, right? It's very rare, right? And so you got to be aware of that, right? You got to keep a close eye on that. You got to make sure it's a willing patient. And, I always said, I could take a stock part and customize it, right? We took stock titanium abutments all the time and cut on them and got them as customized as we could get them to the soft tissue model we had. But, I'm kind of in the dark there, right? I'm kind of eyeballing it in and out. The tissue's not clear most of the time, so I can't see through it. And, maybe I need a 5.15 diameter that's kind of oval. Do I have to buy a 6 millimeter stock and then cut it down to that oval? Most of you probably cut on a piece of titanium once or twice. It's not a fun deal, right? So stock abutments to the customized stage were too hard, right? It just were not fun. So we would typically go another direction. So it became that these stock parts became a choice for when somebody was looking for a lower cost option. And there was a time when it was the lower cost option. And so, yeah, can it be done? Maybe to a degree, right? But I don't know. Right? If I look at these images on the left, right, this graphical representation of a stock abutment with a PFM crown, right? The one on the top is a stock one, the one on the bottom is custom. And, things you should notice, right, is where's the margin? Look at the emergence profile from the implant up. Look at the thickness of the alloy under the crown. And I know we don't do many PFMs anymore. Most of these would be zirconias, but the same argument applies, right? That's a lot of zirconia crown to expect that little skinny abutment to hold up. Was my, as a technician's argument about not doing a stock abutment, that I'd rather do a custom abutment because it was better for the crown. But as I go back now and I look at the tissue and the emergence profile, and yeah, no doubt, I can customize the emergence profile from the margin of the stock abutment up to the cervical margin on the tissue. But what if the angle of that stock abutment is not the angle I need it to be? What if I need to be a little wider, a little narrower, right? I got to start where I got to start, and it's just not fully custom. If I look at the same two abutments, right, from occlusal, it becomes pretty evident, right? the one on the left, that's asking a lot, right? To put a crown over that abutment and expecting the mesial and distal marginal ridges not to shear off, that kind of thing. You need support for the crowns, and custom abutment's going to do that ideally. So, this was always my point. I mean, look at the margin of the stock piece, right? Is it where I need it to start, right? Do I need it to start maybe a millimeter out or a millimeter more buccally, but only 2 millimeters lingually? And, it is what it is when it's stock, right? And I've got to start there. And the anti-rotational things weren't always great on these. Most of that's corrected now, but the internal fit, all those, they're very good. Most of the ones that we used and you should use are FDA cleared, and it's okay. But when I can get a custom abutment, right, and it can be customized from the implant interface up, then now we're really doing something that matches our theory of customization, for ideal results. So, that's kind of my argument. These are a great starting point, right? I've customized this tissue and I want to put something in that hole that matches it ideally, right? Ideally, right? I want my abutment and crown to fit that conical tissue intimately all the way around. So, custom abutments are out there. They're available in so many places, right? And there's so many, variances in prices and all that. And I'll tell you a little bit about why, right? The first question to ask is it fully milled, right? Meaning that is it milled from the occlusal down to the interface, right? Is the part that actually fits inside the implant milled at the factory or wherever the milling center is? The main difference is the good ones, the best ones are. The lower cost ones are not. They're milled from those little things you see on the bottom. Those are blanks, we call them. And you see that the interface is already pre-milled on those blanks. And so the next step is to put it into another milling machine that just mills the top. There's some limitations to how far the milling machines can be compatible, and we can bring down the cervical margin or the interface margin. And so there are limits to that. And of course, the biggest question you should be asking is, does it have FDA clearance? There's a lot of talk in the market, mostly from implant salespeople, that talk about, warranties, and if you put somebody else's abutment on my implant, I'm not going to warranty my implant. I always hated that kind of marketing. I always thought that was a kind of a rude way to do business, that you're going to threaten me. I paid for my implant. I should be able to put on it what I want to put on as long as it's FDA cleared, right? And so I didn't like that, but that's a fact, guys. It exists. You'll hear it every day, and I don't. The implant companies that do that, that makes sense. Protect your brand, right? You want your brand to be your brand, and you want to stay within your own family. So that's where all this argument came into being about you ought to use factory parts on a factory implant. And I get the argument to a degree, but I promise you, it's mostly marketing. It is mostly marketing, because it's not the manufacturer of implants and abutments that make the rules. It's the FDA. And the FDA qualifies something as being cleared or not cleared. And when the FDA gives it clearance, then they're saying it's as good or better than a factory might be, or the OEM might be. So, just ask that question, right? And just keep an eye on that, just to make sure you're using FDA cleared parts. So if an implant manufacturer tells you that an Atlantis abutment will void the warranty on my XYZ implant, you'll say, that's fine, because the FDA says an Atlantis is okay. And if they say it's okay, I'm good with it. And by the way, Atlantis will warranty your implant. Right? It's a pretty cool warranty that Atlantis does do, that if you ever have a problem, Atlantis will not only replace your abutment, but also cut you a check for whatever implant is under it if it's not one of their own. So just ask those questions and look for those good warranties. And so Atlantis kind of leads the way on that. And so this manufacturer-specific part, again, mostly a marketing ploy. And it doesn't mean that they aren't bad, guys. It really doesn't. But there was a time when people like Straumann and Nobel didn't make their own abutments. And, they didn't start making their own because everybody was doing them bad. They started making their own so they could sell them. And, so just ask the questions. And, one of the questions I would always go back with to folks that said, no, I want to use a Nobel abutment on a Nobel implant. And no problem, I'll get it. It takes longer, it costs a little more, but I'll get it for you. And then I would ask, what about the locator we did last week, right? Who makes locators, right? Well, it ain't Dentsply, and it ain't Straumann, it ain't Nobel. It's Zest, and they make locators for everybody's implants. But nobody ever once asked me, right? Is it a original manufactured part? So, we're looking at two different things here, and it's okay here, but not okay there. So again, FDA is kind of the boss of all this, and you just need to go by what they say. Custom abutments, though, right? So when I was dealing with all the stock parts, because folks wanted to save a little money, if we wanted a custom abutment, the only way we had to make it was what was called the UCLA abutment. The UCLA abutment was just a titanium part, a base that fit in the implant of choice, and a plastic or wax top that we would then shape and mold and add wax to, and then cast gold to fuse to the titanium base. So it was a truly handmade custom abutment, fully FDA cleared, and because it was all done by the technician on pre-manufactured parts made by the manufacturers. And we did a lot of those. We got saying, "Hey, we really want to do custom abutments," and this was kind of our only way. But we didn't do as many as we wanted to because they were twice as expensive as a stock, or three times more expensive as a stock. Well, the part was expensive, right? The part cost at wholesale was way more than a stock abutment on its own. Then the lab had to do their work and the gold and all that. So it was a very expensive venture to do a hand cast, hand waxed UCLA abutment, but they worked. Today's world, we're doing computers, right, and CAD/CAM technology, and so now we have computer design and computer-aided manufacturing that allows us to create titanium, gold-colored titanium, and even zirconia abutments that are made in a fraction of the time at a better accuracy and cost a lot less. So we went away from UCLA. I still see them done occasionally, but not often because this CAD/CAM technology has gotten so good and so broad to cover most every situation. And so we moved to digital, by designing the abutments in a computer, letting a computer software help us design a better abutment, and then using a really sophisticated milling technology to mill those abutments out. So, the machines, I think this is a picture of the one from Atlantis. That's a $3 million milling machine that, it doesn't play around with, and it mills from solid stock. So the interface and everything's milled in. So this is what that workflow looks like, right? From a lab, you're going to send your implant impression to the lab that you customized, right? And the lab's going to pour it up, and they're going to put a scan post in it, and they're going to scan the scan post and the soft tissue and all the other data. And, that's from that scan, an abutment's going to be designed, right? And then an abutment's going to be manufactured. And so, we got to decide what kind of abutment we're going to put on it. Now, in the beginning, single unit crowns, we did them all screw retained, every one of them. In the beginning, that's all we did was screw retained. Somewhere along the line, somebody said, "Hey, let's do them as cementable, right? Let's design the abutments as a crown prep would look, and we'll just cement them." And that was done for various reasons: cost, chairside time, all that. And after 8-10 years of that, and then after maybe 6 or 7 years of this, that has changed again. So what you're looking at, of course, here is excess crown and bridge cement that didn't. It was, and it's hard to see, guys. I mean, this isn't bad dentistry. This is actually from the dental school. So I've always been amazed. We thought we got it all right, and unfortunately, some of the earlier cements we used weren't radiopaque, so a little bit of a challenge. But this is what happened, right? That'll get down there, and that'll aggravate the heck out of the bone and the tissue, and pretty soon we'll see a lot of resorption. So if you ever get one like this, where you see the ring around the implant, that's peri-implantitis, right? That's a term we didn't have 10 years ago. So what has happened because of this, right? Folks have kind of shied away from screw retained, cement retained, and gone back to screw retained. Right? And I don't think cement retained are bad. I just think that you have to be really cautious about the crown and bridge cement. But now when you ask labs, and I ask labs everywhere I go all over the country, what percentage of your implant crowns are screw retained again? And it's 70 to 90% everywhere I go. So, the masses have spoken, right? We don't want to deal with that cement anymore. Let's go back to screw retained. So there are multiple ways to look at screw retained. You're going to hear screw retained, screw mendable. Those are all terms. Most of them come from a marketing ploy somewhere, but it's basically a base, a foundation, like the one on the left is a stock part. The lab designs a crown, mills a crown, and glues the crown to that base, and then sends it to you for delivery. The one on the upper right is what we call a hybrid, right? A stock base, a custom created in the computer abutment top, and then a crown to go over top of that. So, two cement areas, but this is a very cool way to do it, especially, in some of the shorter chairside flows. And then on the bottom, a customized abutment, right? We'll talk about that a crown is made over and cemented. And again, most of the time it is cemented in the lab, and, the doctor then delivers it. So a tie base is the original stock part, right, for doing a screw retain crown. Several companies came out with these pretty quickly, and I jumped on the bandwagon like everybody else because the cost was so favorable. But 9 months into it, I realized that we've got a problem here because not many of them had the anti-rotation or the retention that we needed, and we saw a lot of crowns coming loose from tie bases, spinning, not always breaking, some breaking, and then we started seeing some screw fracture because we're asking a lot of this small little skinny post and that screw, right, to hold up these screw retain crowns. And when you do a screw retain stock part like a tie base, right, the hole is all based on where the implant is, and there's nothing we can do about that, right? There is no angulated correction with a stock part, right? The hole is what it is. So, if you use a stock part, the hole's going to be where it's going to be, and you just got to deal with the result of that, which you got to plug that hole with something. So as 9 months passed and I started seeing crowns like this, right, and I'm thinking this little skinny post is going to hold that in place. That's a lot of zirconia. What happened was we started seeing fractures, right? Both fractures of the crown. On a good day, the only thing that happened was the crown became loose from the stock part. On a bad day, the screw broke, right? And you got to deal with that. It's not a great day in the dental office. And I got to checking these things closer and realized at the time, about 9 to 12 months after entry into the market of the stock tie bases, none of them were FDA cleared except the Serona one. And I said, oh, this is not good, right? Because at the time, the FDA was making big inroads into implants and abutments, and everybody was cautious. So I got away from them after about 9 to 10 months because of all the issues and the FDA. Now, some of them now have some FDA clearance, but it's still a stock part and the associated things that come with it. About the same time, the Atlantis guy came by the lab and said, hey, I want to talk to you about custom base. I said, okay, what's custom base? And custom base is Atlantis's version of a screw retain crown. It's basically an Atlantis abutment. It looks just like an Atlantis abutment, but in the computer, it has a lot more variability of angulation and screw placement. So, we can put the hole where it needs to be, so we can customize a tie base through Atlantis. And I thought, this is fantastic. Now, I had to go back to paying more for it, therefore charging more for it. But, I had the safety net of FDA clearance, right? I had the known history of Atlantis. I had the delivery. The customer service of Atlantis is the best out there, hands down. There's not a dentist or a lab guy that will argue that point. You send the scan in on Monday, you get the abutment on Wednesday, 99% of the time. So we had a lot of variability with core height, so we could get the crown support we needed. The emergence profile was shared. It's awesome, right? So when I look at case like this one where the tie base just never stayed in well, right? And you look at where the rim of the tie base was hitting the bone, and now we understand why it wasn't staying in well. But the custom base, right, is customized. It looks like the root of that tooth would be coming out of there. The crown's better. It's just better all the way around. So this became my go-to for a screw retain crown. So if you look at it another way graphically or even on the bench, right? So stock part, right? Stock tie base and custom base. And things you should notice about those two comparatively would be emergence profile, right? Emergence profile is all over the place because of the position of the implant, right? So is that healthy for that tissue, right? Is that natural? Nah. The distal amount of the crown hanging off the stock part, right? Not good. Where's the margin placement? Maybe too low, too high. And then lastly, where's the screw hole, right? Not good. But if I can customize it with Atlantis base, then that was it really changed my world for a screw retain crown. So this became the go-to, and gold hue, Emax crown, it was perfect, right? And you can see on the right, I think none of us, if I'm in your chair and getting a single tooth, I'm absolutely wanting the one on the left and not the one on the right. And they added another layer of design feature to this custom base, and it's a feature called angulated screw access, or ASA. So before ASA, we could correct, I think about 20 degrees, right? So most posterior crowns, easy to get the screw hole in the right place, but a struggle with most anterior crowns, right? You just couldn't get enough. So they added this feature, basically an engineering design that said, okay, we're going to give you up to 30 more degrees lingual access. We call it angulated screw access, and it's just a re-engineering of the abutment milling on the inside, but we're going to have to re-engineer and build a new screw and a tool to tighten that screw, and that's what they did. So they built a new screw head and had the manufacturer of the screw, and one company makes everybody's screw, so all we had to do is say, look, this is the top we need. and the tool to tighten it. And so this thing can attack the screw head at 30 degrees and still torque it the way it needs to be torqued. It's called a hexabular design. And the unique thing about the ASA, Angulated Screw Access with Atlantis, is that the hole is only big enough to get a tool in, right? So when we cement the crown onto this abutment, we actually capture the screw in that cementation, so that the only thing left for you to do is to take the tool and reach in and tighten it up. Everybody else is on the market that has an angulated screw access. They have to have the hole big enough to put the screw in and then the tool. So when you have a bigger hole that can take a screw head, you can't do it on many laterals and not many centrals either. So it's a little limited. So I like the angulated screw access that Atlantis did. Just be careful with this tool, right? Across the room, it looks like a worn out number 8 round burr. So, you got to mark it with something so you don't toss it out. What did I use for cementing crowns over abutments or screw retain crowns? I used Ivoclar's multi-link hybrid or Calibra universal, right? There's a couple others that are popular, but they all work. They're all kind of a hybrid resin, a composite resin, glass ionomer hybrid that sets quickly, dual mix. It's super strong, super quick, easy to use. So the only thing left to do is deal with the hole. So we look back in history. How do we used to deal with the hole? Well, we used to put cotton pledgets down in there and put composite on top. But as you well know, if you open that up in a couple of years, it doesn't look too good because cotton just doesn't, repel anything well. So cotton will be black and grungy. So we've gone to Teflon tape. Most everybody does this. You go to Lowe's and buy this for $1 and you just, wad up a little piece of Teflon tape and put it down first and then cover it up with composite. And if you get leakage, the Teflon's not going to have any blackness or mold or anything grown to it because it's Teflon. And then post your composite, polish it up, and you're done. Now, I would tell folks that if you're using the angulated screw access and you have it's a special screw, a special tool, you want to be reminded of that if you ever uncover it. So they make Teflon tape in different colors. So, get you a different colored Teflon tape to use on those oddball cases where oh, I got to go get that special tool. It just helps remind you if you uncover it and you don't put the wrong tool in there and strip the heads. So I always would give people seating jigs. One of the common calls we would get is, the crown's not seating, and without a seating jig, that abutment can actually go in, one of 6 or one of 8 ways, depending on the system. And it's easy to get it off one hex turn, right? And then, of course, the crown's not going to seat. So seating jig, eliminates all that. And so I would hand make it out of a light cured composite, and that's easy and quick. But when I use Atlantis, we would always order the Atlantis seating jig, which was a 3D printed, customized to the abutment individually, and went all the way down to the margin. It just made things better, right? It just was easier to seat an abutment with one of these. They call it Atlantis AIG insertion guide or something. It's very, very cool. So, custom abutments. Atlantis leads the way on that. It makes it for almost every 135, 138 platforms, and that was always my go-to. That's kind of the big red button, right? Full FDA clearance, easy, they come quick, and there's not many implants I can't get them for. So that's my go-to, even still today. And I was a lab guy for 40 years. I'm only a Dentsply guy for 5, and I'm not a commission guy, so I don't get anything about what I talk about, but it's still my go-to. So digital, right? So when we go digital and, with implants, it's really a good asset to start moving that way with your practice, especially if you have an intraoral scanner. And so people, ask me why are you showing a cotton field on a conversation about implants and digital? I said, well, this is my buddy, Rusty, that is a 4th generation farmer, one county over. And it's amazing to watch his journey into digitization at the farm. And so one of my favorite things to do is to go out in the spring when he's planting and go out in the fall when he's harvesting, and just to see, okay, how far have you advanced and how has it helped you? So in the spring, it gets into a tractor much like this, and you get inside and you look and say, oh my gosh, look at all this technology. And, his planner actually drives itself, powered or directed by GPS, right? And it will plant seeds to within a 1/4 inch of where it planted seeds last year, which is important when you're growing cotton. I didn't know that until Rusty taught me, but it is important, right? You want your seeds to be close, makes it easier for the next plant to grow. So, I get in the cockpit with him, and, this thing sets off to planting cottonseed across a field a mile wide, and turns around at the end and comes back and is doing it all himself. And it's just wow. If you can do this, why can't we do something really cool in dentistry? And of course we have robotics now. You know, and so we look in dentistry, and it's starting to change now, but still, I'm still a little surprised that when I go out and I see somebody doing an implant impression, that they're still using traditional impression techniques, right? If you've got a scanner, right, and you've been scanning teeth, there's no reason today that you can't move away from this type of implant impression. Right. This is a very scary implant impression, right? Those are 8 implants, and that's a lot of screws and a lot of parts and a lot of things to get right, right, at that appointment. So that's kind of an anxiety-driven appointment, and it's fun, it's engineering, and it's cool. But I can tell you that if that's not 100% right, and if the technician feels any movement of those impression posts inside that impression, they're going to ask for a new impression, and it's just no fun. It's easy to say, hey, I'm going to use my wand this time, right? I'm going to put a post in there and I'm going to scan it. Right. And it used to be that we could only do singles, but now we have the technology that we can do multiples. So you just need the appropriate scan post, right, and the scanning instrument, right, and our prime scan kind of leads the way in this accuracy. So there's multiple paths you can take this, and I see all paths. We're certainly not going to talk about the in-office because most of those guys know what they're doing, and there's plenty of training out there on it. And besides, data tells us that 97% of implant abutment restorations are done through a lab workflow. So let's spend the time where it's done. So there are some docs that said, I'm going to do a hybrid, right? I'm not going to build everything myself, but I'm going to scan it and send it to a company and get them to make my abutment. But just realize that if you do that directly, you're going to scan it. It's going to go to whoever's designing it, and they're going to send you a file back, right? And you're going to have some sort of software and some at the time to get online and confirm their design, right? You have to check it. Nobody's going to mail an abutment without you checking it. And so you have to remember to check your email frequently and know when your design's coming, because if you forget, right, and then 2 weeks later you're looking for your abutment and you say, "Where's my abutment?" and they'll tell you didn't come check it, right? So you got to check it. And to me that just doesn't make sense logically in a dental office, right? You checking abutment files, and some of you like it, and that's great, but you got to do that, right? And that's go back to the manufacturer. They're going to build it and send it back to you, right? And then you're going to build your crown, or you can send it to the lab from that at that point. Let the lab build your crown. So there's multiple options. We create this thing called a core file at Atlantis that makes it better. Again, 97% use this workflow, right? It's where all this the clinician has to do is scan it, right? You scan it and send it to your lab. Right, and the lab is the one that does the interfacing with the milling manufacturer, right? So they'll check everything. They know your preferences. They do it quickly, and they handle the abutment. Okay, and they build the crown, or they can send you the file if you have a milling machine. You want to mill your old crown. Yeah, I did it different ways for different folks, whatever you want to do. But again, most of them are done all in the lab, and all the clinician has to do is scan and then deliver the abutment crown. So, how do you decide which way to go? Well, again, I think 97% of you already decided to go to the lab. And I can just tell you the easiest way that I've seen in any office that I've been in, either assisting or helping with problems when they're scanning for abutments, they're doing direct. I watch the assistant, I watch the dentist, and I watch them go through the process, and it takes them 20 minutes, 30 minutes, right? And I go in a lab and watch a lab take a model, put a scan post in it, and time them, and it takes them about 5 or 7, right? It's just, and in my lab, I had somebody that did this all day, about 20 to 30 a day, and that's what she did. So she did it all day, every day. So she was good at it, right? Practiced, right? When you go in a dental office, the dental offices will do this once a month, maybe, and so you kind of have to relearn it every time, and so it's just time. If you want to spend that time, that's okay, right? Just allocate for it and charge for it, because what could you be doing with that time if you weren't doing that, right? If you weren't spending 30 minutes checking a design or doing those things, could you be cutting another crown prep, which would financially be better? So I think the lab workflow is better for the dentist, not being just the sensitive lab guy, but for the dentist for his own pocket or her own pocket. So if you haven't been in a lab lately, right, to give you some reinforcement about how technology advanced labs have become, you just need to go see it, right? It is amazing to watch a technician put an impression, put a model, or receive an intraoral scan, right? And basically, they're working in the virtual world now, so they see your case on the screen, and they're designing crowns on that, and sending it off to a milling machine. And labs have these really sophisticated printers and milling machines today that can, again. Most techs, good techs, design techs can design a full contour zirconia crown in about 7 minutes. And it's just pretty amazing. Then you send it to a mill, and the mill replicates that, and then of course you put the final color on it. And of course we're using technology to print dentures today, and so if you should go to your lab and see how far they've advanced and what they're doing with digital technology, because that all relates back to you, right? Even back to this earliest iTero doc we had, right? You're going to scan it, right? It's going to come to, our tech at the top right. She's going to take that scan. She's going to design that molar. She's going to send it over to a mill. And we may or may not print a model. If it's a monolithic, don't really need to even print a model. So then the next thing the doctor does is deliver it. So scan and deliver at the next appointment. And it's all digital. It only makes sense that we would do this in the implant world, right? So this is at a periodontist office that I worked with in Columbia, South Carolina, and helped him get a scanning device, one of the old iTero machines, and they still use it today, right? And so we developed a program for all their referrals that the periodontist would place the implants, they would scan the implants, and they would send the file to me. I would pick up the phone and call the GP and say, okay, I got Mrs. Smith's case, what shade, what kind of crown we want to put on it, and get that information from the GP and fabricate the crown, deliver it. And the periodontist took no billing other than the implant, right? So all the billing for the abutment, the crown, the placement was done by the GP. So it was a win-win-win for everybody, and it really digitized the workflow, and it made it faster. At the time, we were doing a lot of the encodes, and that's what they were scanning. And again, I would get that file and fabricate the abutment and the crown in the lab, and then deliver it to the GP. And this is one we did in 3 days, right? We scanned that at the periodontist office on Monday morning, and we delivered the abutment crown on Wednesday afternoon. And I'm not saying all labs can do that, or will do that. I'm not sure I did it for every case, but it's good to know that if I have to, I can and could. So what do you need to know? Well, you need to know what implant it is, right? Because you have to have the appropriate scan post. It's unfortunate that these guys won't get together and say, right, hey, let's play together, right? Let me use your scan post file, and if they want to get something else, right? But they don't, guys. So just know that, right? If you're doing a Straumann case and you want a Straumann abutment, then you got to use a Straumann scan post. Period. Right? If you want to use the Sirona scan post at the top, but you want Atlantis abutment, you can't. Right? If you want a Nobel abutment, you can't. So you got to have the appropriate. So you got to know that. Used to be that we would warn you to make sure that your scanner recognizes scan post. That's not a problem anymore. Most all do. And you probably should give a quick call to the lab you're using and ask them, I'm going to do this, and this is the scan post I've got. Is that okay for you? The lab software can recognize what they're doing. And, I get asked quite often, what's the most, if there is a generic scan post I can get that covers most bases? Well, there's no other one but Atlantis, right? Because, again, they have a scan post for 132 different implant styles and types. And so it's all going to the same place, the Atlantis abutment. So the DI devices, PrimeScan, Trios, iTero, all are good, right, to do this with. Just get the scan and go. Dentsply again leads the way here. They've introduced last October, over a year now, the Flow S's, which is really a sophisticated scan post. I know it looks a little plain because it's cylindrical in nature, while everybody else has a unique circle or triangle or something, but there's like 20,000 little crystals on this thing. And this thing was designed to take advantage of the accuracy of the PrimeScan device, the latest scanner that PrimeScan has. With the PrimeScan scanner and this scan post, we get super accurate scans. So much so that we can get a metal substructure for a zirconia top, either in a 3-unit bridge or a 18-unit bridge, and we don't do verification appointments anymore. That's how accurate these scan posts and scanners are. So it's literally put the 3 posts in, scan it, send it to the lab uploads it. The framework is designed by Atlantis. A core file is sent back to the lab that same day, so the lab can start the zirconia build it, fire it, and then cement it to the metal framework, and you deliver a 3-unit screw retained crown in as little as a week, and without a verification appointment. And yes, we can even do it on more units. So Or this is QR code for my contact if anybody needs me, but of course we're here with one of the best lab networks in the country, and they have plenty of people that can help you as well.